In this video, we will discuss DC machine introduction part, principle and working construction. This concept common for all the engineering students, first semester physics cycle, module number 4, right? So DC machine either it may be a generator or motor, DC generator or DC motor operates by DC supply. That's why it is called a DC machines, right? Motor which converts electrical to mechanical, and generator which converts mechanical to electrical. So first I'll see the principle like DC machine principle and DC motor principle. So we are having three major principles. At least you should remember any one. Okay. What about the Faraday's laws of electromagnetic induction? Faraday's first law: when conductor cuts the magnetic field, EMF is induced. Right. Magnetic field is constant, conductors are rotating, conductor cuts the magnetic field, EMF is induced. In the 10th standard and PU classes, we studied dynamo, right? Similarly, we are having generator over here. And second one, Fleming's right hand rule is for generator. Those three fingers, I mean like thumb, middle finger, forefinger are mutually perpendicular to each other. Thumb shows motion of the conductor, forefinger shows magnetic field, and middle finger shows induced voltage or induced EMF. Right? That is Faraday's Fleming's right hand rule. Right? And also dynamically induced EMF. What is that meaning? Dynamically induced EMF. Conductor is rotating, magnetic field is stationary. See, we are having two types of classifications. Classification in the sense like two types: statically induced EMF and dynamically induced EMF. So what about statically induced EMF? What is the application? Statically induced EMF, conductor is stationary, magnetic field is rotating. Which one will you give example? Third module we discussed, right? So transformer is the best example for statically induced EMF. Conductors are stationary, magnetic field is rotating from primary to secondary. That is flux linkage between primary to secondary. That is statically induced EMF. Here the motor or generator, dynamically induced EMF, dynamically everything, because movement will be there, motion will be there. So dynamically induced EMF, conductor is rotating, magnetic field is stationary or constant. And also Lenz's law you have to remember, because Lenz's law opposes the cause producing in it. So that is also applicable. These four laws you must remember, okay? And DC motor somewhat different, right? So DC motor, when a current carrying conductor placed in a magnetic field experience a force or torque. So current carrying conductor placed in a magnetic field, what happens? There is a stationary magnetic field, and constant magnetic field, and conductor carries rotating magnetic field or circular magnetic field. So interaction between those two, what happens? Experience a force, right? That is the working principles of DC motor and DC generator. And next, where we are using these DC machines or DC motors or DC generators. These DC motors, we are having different types like shunt, series, compound motor. Shunt motor is for constant load application. Series motor is for heavy load application, high speed application, variable speed is possible both, but constant speed application, constant motor, that is shunt motor or shunt motor. Shunt generator and shunt series generator. Series generator is for welding generators and arc lamps. They are using series generator. Shunt generator is like electroplating, electroforming, that fuel cells charging purpose. They are also using this type of shunt generators. Compound motor, combination of both, okay? And principle I told you, right? So Faraday's laws of electromagnetic induction, Fleming's right hand rule, left hand rule is for motor, and dynamically induced EMF, Lenz's law, and all. Working and construction we will see one by one now, okay? So DC machines, module number 4. As you can see the diagram, see this is a brushless DC motor and shunt motor, series motors and all. I have taken picture from the laboratory. So fan is for cooling purpose, and yoke is the outer core of the machine, and also mechanical input we are giving, that is a I mean like fans for cooling only, mechanical input in the sense turbine or whatever, and lamp will be glowing over here, right? These are the brushless DC motors also present. Like stepper motors are there, by supply DC only. Servo motors are there, special type motors, right? Okay, like servo motors, linear induction motor, stepper motors, and all special type of motors. Okay, operates AC. Keep it in your mind. But DC motor here, shunt motor, series motor, compound motors. So model number 4, working principle generator and motor, construction of generator and motor. See here, this part is motor, like stator part. This one is a rotor part, rotating part of the machine. Fan is for cooling purpose. Commutator will be there present, winding will be present, and field windings are present, field poles are present. So working principle, electromagnetic induction. When a conductor cuts the magnetic field, EMF is induced. Faraday's laws, and rate of change of flux linkage occurs directly proportional to induced EMF, that is Faraday's laws of automatic induction. Okay, and dynamically induced EMF, conductor is rotating, field is stationary. Fleming's right hand rule is for generator. So 3 fingers mutually perpendicular to each other. Thumb shows motion of the conductor. Middle finger induced EMF, and this one 4 finger shows magnetic field. Similarly, Fleming left hand rule is for motors. Okay. Right hand rule is for generator. Faraday's law, dynamically induced EMF. The working principle. See here, I'll just giving you some information how the DC generator or motor works. Here there is a output if it is a generator. If it is a motor, we have to give power supply. Motor will start rotating. So that when coil starts rotating, the rotation will be there. Cuts the magnetic field from north pole to south pole. There is a magnetic current. What happens? Conductor cuts the magnetic field, EMF is induced. These are working, overall working. Okay. So dynamic we studied, right? Same thing here also. So next, constructional part of DC motor and DC generator. See. So this is the yoke for the machine. And also stator part of the machine. This one is a rotor. This one is a rotor. The contact. This is a stator part of the machine. See this big picture. I think you might have seen in childhood days and all. Small DC motor used to play with that motors, right? Like remote cars and then some toys and all. They used to keep motors. That motors are permanent magnetic DC motor. Permanent magnetic DC motor, we are giving power supply, that motor rotating. If you rotate that one, it will give lamp lightning, right? So same thing, this is a rotor. Okay, he is having the rotor slats and rotor armature conductor, and then bearings, shaft will be there. So this is a constructional part of DC motor or DC generator. If it is generator, we are getting power supply from the rotor, from the rotor conductor. If it is motor, we are giving power supply, it starts rotating, right? So yoke is the outer cover of the machine, and also it avoids entering of dust particles, moisture contents inside the machine, and rotor and then stator will be there. Stator is stationary part of the machine, rotor is rotating part of the machine. Pole core is for holding the field winding, pole shoe is for enlarging the rotor core area or enlarging the flux, and field winding is for inducing the flux purpose or creating the flux purpose. You want magnetic flux, right? So that's why. And also rotor slats is for holding the rotor armature conductor. Rotor armature conductor is for inducing the EMF because work has to be done, right? And commutator is for collecting the current from the armature conductor, and also converts AC to DC because DC output we want, right, for the generator. And also brushes is for collecting the current from the commutator, and shaft is for holding the overall rotor, and bearings is for smooth operation, reliable operations. See here, F1, F2 is the field supply we are giving this supply for exciting the field winding or to creating the flux purpose, right? So base is for mounting purpose, right? This is the construction part of DC machine. See here, stator and then rotor. Rotor is the rotating part of the machine, stator is the stationary part of the machine. Here stator, pole core, pole shoe and yoke made up of cast iron silicon steel, high grade silicon steel, and rotor conductors and commutator, field winding made up of copper, and brushes made up of carbon or graphite. Shaft is also made up of cast iron and silicon steel. Okay. These are the constructional part like stator and rotor. Rotor is this one. Rotor part is this one. See here, commutator, this one, slats, armature slats, armature conductor, brushes, and bearings. Bearings is for smooth operation to level operation. Spring is for to move the brush contact into commutator. This is the stator. Okay, stator. This is the overall construction of DC machine. Okay, bearing is for smooth operation to level operation. Commutator is for collecting the current from the armature conductor, and also convert AC to DC. Shaft is for holding purpose. Okay, you can draw 2-pole machine also, and then 4-pole machine also. Okay, these are the construction features, the construction part of DC machine. So you can draw any one diagram. Okay, thank you. Next we will see the all parts and EMF equation.